Welcome students. Today is the first lecture which we are going to do on the chapter force. Okay. You already have an idea what is force, but let's start from the beginning, the scratch itself. So, what is force? That is what we are going to deal with in this section. Okay. So, force. The very layman language of force or understanding of force is basically push or pull. Push or pull. But it is much more than that. What is force? Or what is the mathematical structure of force? That too you learned in previous classes. What is it? F force is equal to mass times acceleration. Mass times acceleration. Or we can write F is equal to ma. This is the equation we already learned in last year. Now, how it came actually? How this equation comes? So, in order to understand that, we have to know the Newton's second law. From Newton's second law, we can derive this equation F is equal to ma. So, what is Newton's second law? Newton's second law. So, Newton's second law states that a force applied, the external force applied on an object is directly proportional to the rate of change of momentum. Okay? So, Newton's second law states that the external force applied on an object or a body is directly proportional to the rate of change of momentum. So, what is, first of all, momentum? Momentum we learned previously. What is momentum? Let's just go into it. Momentum. So, momentum is the product of mass and velocity, or it is mass times velocity is momentum. We can write momentum P, it is represented by letter P, is m times v. This is very important to remember. P is equal to mass times velocity. The SI unit of momentum is kilogram, because mass is kilogram and v is meter per second. So the SI unit of momentum is kilogram meter per second. Right. Coming back to Newton's second law, how we can write this in mathematical expression? What? F is directly proportional to rate of change of momentum. Okay. So let's go into it. So coming back to from here, we can write it. F is directly proportional to dp upon dt, or you may not know what is d here. So we can write F is directly proportional to delta p divided by delta t. This d means differential, that you don't have to worry now. You don't have to worry about it. What is delta p by delta t? What is delta means? Delta, it have two meaning actually. Usually it is refer change in something. For instance here, change in momentum, and it represents interval as well. Interval. For instance, here delta t in the denominator, delta t you can see, right? So delta here, it means delta is interval, and in the numerator you can see delta, it is change in momentum divided by interval of time. That is what this means. Now here obviously you can see a proportionality sign over here. So using experimental ways, by experiment we can find the constant of it, and that constant we usually represent it is k delta p by delta t, and this k value is actually 1. Can be figured out experimentally. Can be figured out experimentally. I hope there is no doubt. Right. So then what is F? F is equal to, we can simply write delta p by delta t, and delta p by delta t. Okay, now what is delta p? Delta p is obviously change in momentum. Change in momentum. Okay, if it is change in momentum, that means it is delta times, what is p? Just before we wrote it is mass times velocity. So we have to write it is mass times velocity. Change in mass times velocity. Okay, now with respect to what we are actually seeing the change in momentum, with respect to time, right? As time progresses, how much momentum will vary? That is what force is. Now for an isolated system, mass is independent of time. Mass will not vary with respect to time. The amount of matter will be constant, right? That means this mass is independent of change also. So we can write the change in momentum delta times mv can be written as m delta v. Remember we are just talking about delta p. Now substituting this delta p is equal to m delta v back to this equation, what we will get? F is equal to m delta v divided by delta t. Now look carefully, what is delta v by delta t? Change in velocity with respect to time. It is called acceleration. Delta v by delta t is equal to a. Clear? I hope you have no doubt. That's how we got what F is equal to ma. And what is the SI unit of it? Mass times acceleration. It should be SI unit. Okay. SI unit is, we can directly from the equation what we can write, kilogram meter per second square. That is what A is, meter per second square, isn't it? So kilogram meter per second square, this is we call with one name called Newton. Newton, right? So SI unit of force is Newton, and it is represented by letter capital N, right? Then I'm asking you, what is the CGS unit of force? CGS means what? Centimeter gram second. This is what CGS, right? Now when we convert this Newton to centimeter gram second, it is called dyne. The CGS unit of force is dyne. dyne. Now 1 Newton is how much dyne it is? This also you did in 9th grade, but we will just go to it. 1 Newton. 1 Newton is actually 1 kilogram meter per second square, isn't it? Now converting this 1 kilogram to gram, what it becomes? 1000 gram, and meter to centimeter, that is 100 centimeter per second square. That is how much we got? 10 to the power, this is 10 to the power 3 right? And this is 10 to the power 2. So we will get 10 to the power 5 gram centimeter per second square. What is gram centimeter per second square? That is dyne. So 10 to the power 5 dyne is equal to, or 1 Newton is 10 to the power 5 dyne. Hope you understood this much. Is there any doubt? If you have, you can contact me through the app or through the mail ID. Now, you don't have to worry about these notes. These notes will be provided. This is one note. So this link will be provided in the website and in the app. So you can easily access the note. But my suggestion is you should make your own notes. That will help you in the longer run. Thank you. That is the first part of the lecture.